So this is another question from JEE Advanced 2018 Physics part. This question is from paper 1, question number 11. This is the circuit given. There are 3 capacitors and there is a cell, there are 2 switches. Since you are watching this video, I assume that you haven't been able to solve this problem. Or even if you have solved this problem, it must have taken you a long time. You can solve this problem under 3 minutes if you know the concepts and if you know the approach how to do this. I have seen on YouTube the solution of this problem done by a leading institute of Kota. The method they use is different than the method I will be using. You watch that video also, then you compare the methods and decide for yourself which is better for you. Then you please write in the comment how you have found this method. Because many students are watching my videos, but only few of them have given comments. So I am not getting an idea how you students are finding my videos. So after watching this video, please write your comments. And of course, if you like the video, you give your like and you can subscribe to my channel. See, if you haven't been able to solve this problem, it doesn't mean you do not know the concepts. Actually, after I solve it, you will realize that you know all the concepts. They are easy concepts. Only thing, you did not know how to tackle the problem, the approach for this problem. In my videos, I don't only solve a particular problem. What I am trying to do is, I am trying to teach you how to analyze a problem, how to break it down into small parts, then how to decide which formula to be used where. I am trying to develop your thinking capabilities so that you can tackle any new problem by yourself. That is why my videos are longer than other people. I just don't solve the problem. I want to develop your problem solving abilities. Okay, so watch the video till the end. I speak a bit slowly usually so that it goes into your mind. You can think, you can grasp what I am saying. Another reason why my videos are longer than usual. Okay, now let's tackle this problem. See, the question says 3 identical capacitors C1, C2 and C3. C1, C2 and C3. The circuit diagram is given of capacitance of 1 microfarad each. So straight away we write 1 microfarad here because we do not want to keep unknowns here. We want to replace with known values here. Okay? And they are uncharged initially. Fine. They are connected in a circuit as shown in the figure. CO1 is then filled completely with a dielectric material of relative permittivity epsilon R. So now this is filled with a dielectric. So if it is filled with a dielectric, will its capacitance remain as 1 microfarad? No, you all know. This will increase. It will become epsilon R multiplied by this. So this is its new capacitance. Here we are using the concept, if a capacitor, when it is air filled, if its capacitance is C, then if it is filled with a dielectric of dielectric constant K, its new capacitance becomes K into C. So instead of K, they are saying epsilon R. So this is epsilon R into 1 microfarad. This much is the new capacitance. Okay. Now it says the cell electromotive force V0 is equal to 8 volt. So this V0, this is equal to 8 volt. First, the switch S1 is closed while the switch S2 is kept open. So this is closed now, this is open. So then when the capacitor C3 is fully charged, when capacitor C3 is fully charged, then they are saying they will open this, they will close this. So before going into that, When this becomes fully charged, what happens? Now think about that. Before opening this, closing this, at this stage what happens? Say this switch is open, that means nothing will flow, current will not flow through this. So this will not get charged, right? This will get charged and they say this becomes fully charged. When this is fully charged, since the EMF here is 8 volt, the potential difference here will become 8 volt, right? If the potential difference here is 8 volt, what will be the charge on this? You know, we have this formula, Q is equal to C into V. So C is 1 microfarad, potential difference is 8 volt, so Q will be 8 microcoulomb. Right? So capacitor, this capacitor will have a charge of 8 microcoulomb. Okay? Now they say S1 is open and S2 is closed simultaneously. So S1 will open and S2 is closed. When all the capacitors reach equilibrium, the charge on C3 is found to be 5 microcoulomb. That means the charge here has decreased, it has become 5 microcoulomb. This is data given. Clear? So find the value of epsilon R. So we have to find epsilon R. This is the question. Okay? Now see, first you decide this is from which topic. This is quite simple, even then I am mentioning this. So in the question it says, when this is fully charged, then they switch this open and this is closed. And again, after that, they say, when all the capacitors reach equilibrium. That means the situation in this question is when the charges are static. So this is from electrostatics. This is not from that topic where the capacitor is being charged or decay of charge in a capacitor, or which is the chapter on AC, which comes later. Okay, so this question is from electrostatics, right? Okay, now let's proceed. Let's solve it. Say, the question says the charge on this from 8 microcoulomb, the charge on this capacitor becomes 5 microcoulomb. That means the charge is decreased by 3 microcoulomb. So where is this charge gone? The charge has come to these two capacitors because the charge is conserved, as you all know. So this 3 coulomb charge comes to these two capacitors. Okay? Now see, I think you know, when two capacitors are in series, if the charge on this capacitor is Q, then the charge on this capacitor is also Q. Do you remember this? When I teach this topic of series connection of capacitors, I always stress this point. We will be using that concept here. When 3 microcoulomb of charge comes to these two capacitors, that means this capacitor will have 3 microcoulomb, this capacitor will also have 3 microcoulomb. Okay? Clear? This situation. Now see, we know this capacitor capacitance is 1 microfarad. The charge here is this much. Use this formula. Q is 3 microcoulomb. Capacitance is 1 microfarad. So this will cancel out. So this V will be 3 volt. Right? That means potential difference here, this will be 3 volt. Understood? Potential difference across the capacitor will be 3 volt. Now come here, think about this. The charge here is now 5 microcoulomb. Again use this formula. This is the charge here, this is the capacitance. So this by this is the potential difference here. So potential difference here will be 5 volt. Right? If the potential difference here is 5 volt, potential difference here is 3 volt, the potential difference here will be 5 minus 3, 2 volt. Simple. This is 5 volt, this is 3 volt, so this has to be 2 volt. 3 plus 2 is 5. Right? Now, again you use this formula for this capacitor. The charge here is 3 microcoulomb. Capacitance is epsilon r microfarad. V is 2 volt. So this cancels out, micro cancels out. So epsilon r becomes 3 by 2, that is 1.5. So this is the answer for this question. But you have to be careful because in the instruction sheets they have said that you have to write it to 2 decimal places. So this will be 1.50. So the answer for this question, epsilon r, is 1.50. Clear? See, the concepts we have used are very simple. Very simple formula. When the capacitor is connected to a cell, when this is fully charged, potential difference 8 volt, this will be the potential difference 8 volt. Then when this is connected, some charge will flow here. So the potential charge is, how much charge is flown? 3 microcoulomb has come here. Then we have used this concept. So this will be 3 microcoulomb here, 3 microcoulomb here. If we know the charge here, we know the capacitance here, we know the potential difference here. We know the charge here, we know the capacitance here, so we know the potential difference here. So this minus this is the potential difference here. We know the potential difference here, we know the charge here, so we can find the capacitance. Simple. Once you know these concepts, once you go step by step in this direction, you can solve this problem in 3-4 minutes. The allotted time for this problem. In fact, if you are fast enough, you can do it in 2 minutes. Clear? In fact, I did it mentally under 30 seconds. But there is a difference between me and you. You are a student and I have done my PE from BITS Pilani in electrical and electronics engineering. So this is in my branch. So obviously I'll be fast. Okay. But anyway, even when you are clear on this, you can do it in 2-3 minutes, the most 4 minutes. So I repeat. So you knew all the concepts here and simple formulas. You remember these formulas also, but you could not solve it because you did not know how to think, how to analyze the problem. That is where my videos will help you. I am trying to improve your problem solving abilities. If you like my teaching, if you like the way I have taught you, please give your like, give your comments. And if you haven't subscribed yet, please subscribe to my channel. From your comments, I'll be able to know how beneficial my videos are turning out to be for you. So please comment. Okay. Bye.